Today's lesson is a continuation of section 8.4, using scientific notation. In the first part of this lesson, I talked about how we can use some of those rules we've learned so far in this chapter to simplify problems that have scientific notation, or that have numbers with scientific notation. And I think I went through an example or two. I'll show us a few other examples here, and something else that can happen though when we start simplifying these problems. Something we got to be aware of. Like I said in the first lesson, we talked about what numbers look like when they're in scientific notation. Well, sometimes we need to make sure that our answers stay in scientific notation, as the question might say here. So, looking at this first example, and again, this is kind of like the ones I went through in the first part of this lesson. Again, if you need a little refresher, you can look at that lesson too. But looking at this first one, I have the hint down here that this problem, 1.5 times 10 to the 14th times 1.3 times 10 to the 20th, I'm multiplying these two numbers together, and they're both in scientific notation. My hint was that, well, it's kind of like this problem that we've done earlier in the chapter, where I'm multiplying two terms together. This is, again, some number times, and actually I think I underlined, but this is some number times, well, some kind of power. And again, some number times some kind of power, and I'm multiplying both of those things together. Well, again, that's really what's happening up here. Some number times some power times some number times some power. So again, the same things I did in a problem like this, I can also do up here, as we'll find out. So I can multiply in the problem below, which we've already done earlier in this chapter with the exponent rules. I can multiply 3 times 2 and get 6. And then x squared times x to the 5th is where I add the two exponents and get x to the 7th. So I can do the same thing up here in this top one with scientific notation to simplify it. If I'm going to multiply those two numbers together, I can just multiply 1.5 times 1.3, see what I get there. And I'll punch that in my calculator here quick. It's 1.95 times 10 to the, well, just like I did below, here's 10 to the power of 14, and here's 10 to the power of 20. And since they're really multiplied together, again, I can just add the exponents, just like the rule we did earlier in this chapter. So I'm going to get 10 to the 34th power. So 1.95 times 10 to the 34th power. So again, that's a good problem. And that's something we can do using our former rules. I'm going to show us, though, with this next example, that sometimes we have to be aware of what we get for an answer when we're dealing with these numbers in scientific notation. So certain things can happen, and we might have to change our answer a little bit to make sure we have it in the correct scientific notation. So this next example, 1.5 times 10 to the 14th over 3.5 times 10 to the 11th. Again, showing you a hint here, is it's kind of like problems we've done below in this chapter, or before in this chapter. 15y to the 4th times, or divided by 3y squared. I can divide these two numbers. 15 divided by 3 gives me 5. And then the y, the variable y, is y to the 4th over y squared. I can subtract those two exponents and get y squared. So this really reduces to, or simplifies to, 5y squared. Well, again, I can do the same thing up here as well. I'm going to take 1.5 divided by 3.5 and see what I get. Well, I'm going to get, and I'll round it off too to help us out, but I'm going to get, well, 0.428, I'm just going to round it off to the nearest hundredth for this particular example. So let's just go with 4.3. So 0.43. Sorry, 0.43 if I round that off. Okay. Well, then using my exponent rule for this part, I can still subtract those two exponents, and I'm going to get 10 to the 3rd. And you might think that, well, this is my final answer. But here's the thing. Again, take a look at that answer very, very carefully, and then think back, just kind of showing us a page I had on the previous lesson. Think back to what we talked about. What kind of numbers are in scientific notation? Okay, looks kind of messy in here, but I'm just going to remind us that these were the numbers that were in scientific notation. And also what we wrote down for the definition. What has to happen for a number to be in scientific notation? We can only have one number to the left of the decimal point. So this number, and it kind of looks like, actually kind of looks like this answer here almost, 0.42. That one we said was not scientific notation. Let's go back to the problem we just did. 0.43 times 10 to the 3rd power. That is actually not scientific notation exactly, because I do not have one number to the left of the decimal. So what I've got to do with my problem now is I've got this for the answer, which isn't wrong, but now I've got to move the decimal one more spot back here And so this really becomes, I'm going to kind of clear some things out of the way, but I need to move that decimal so that I have it in scientific notation. So I just have one digit to the left. So really I need this to be 4.3 times 10 to the, well, it was to the third power, but now what power is it going to be? Well, if I look at this number, it would have been 0.43 times 10 to the third. So I could have jumped it 3 times. I would have jumped the decimal 3 times from where it is right now. And really, what number would that have been? Well, it would have been the number 430. So how do I write that problem really in scientific notation? Well, yeah, it's 4.3. That's where I want the decimal. But it should be 4.3 times 10 to the second power now. So notice what happened. Because I had to move the decimal one spot back towards closer to 0, well, now in case I had to decrease the power from 3 to 2 to make that work. So in problems in this chapter, we can use our rules like we've done in the past. But sometimes when you get your answer, make sure it's in scientific notation. If it's not, we may have to do a little change in here, kind of like we did with this one. We have to change it into scientific notation, the decimal part. And it may modify, or we may have to also fix then what power of 10 we have that number in scientific notation to. I'll go through just a few other examples too to again show you what it might look like in the book, and again to show us maybe some of these cases where we might have to change the answer, might not, but we'll go through a few more examples too just to make sure we're comfortable with doing these kind of problems. Number 4 here. So this example says 4.5 times 10 to the 5th divided by 1.5 times 10 to the negative second. So in this problem, again, we're dividing, but we know some rules when we're dividing. If I'm multiplying two things together and I have some powers over here, okay, what I can really do is I can just divide these two numbers and then just use a rule for these two powers, and that should give me my simplified answer in scientific notation. Kind of like I did with one of the examples above, that second example we did. So 4.5 divided by 1.5 just gives me 3. And that times, well, if it's 10 to the 5th divided by 10 to the negative second, I would subtract those two exponents. And that's going to give me, well, 10 to the, it's 5 minus negative 2, give me to the 7th power. So 3 times 10 to the 7th power is what I get for that answer. And again, you could even punch in your calculator to make sure that is right, but I'm going to tell you on this quiz and on the MCA problems, you might not be able to have a calculator. So but we can definitely figure it out just using what we use there. 3 times 10 to the 7th power. Look at number 5 here, and I'm actually going to change number 5 just a little bit because I do want to talk about, again, one where you might have to change the answer at the end. So change this as opposed to 1.1. I'm going to change this to 7.1 times 10 to the 7th. So I'm going to change this problem just a little bit. Times 4.2 times 10 squared. Okay, so change the problem into that here, and that's what we're going to look at. Don't ignore that top part up there. Let's imagine this is the problem instead. Well, this problem, like one of the examples I've done already, again, we're multiplying these two things together. Okay, next to the parentheses next to each other tell us we're multiplying these two things together. So what I can do is I can just multiply these two numbers together, 7.1 times 4.2, and see what I get there. That'll give me the decimal portion of this number. I'm getting 29.82. Okay. That times, well, now with the powers, I can apply my rule. 10 to the 7th times 10 squared. I'd keep that same base, add the exponents, I'd get 10 to the 9th power. So again, you might think, okay, well, this is the end of my answer. I got 29.82 times 10 to the 9th. But really, this isn't going to be quite the answer if you think about it. Again, well, first realize it's not in scientific notation. Okay, just giving myself some more room here. It's not in scientific notation. Remember, what do I have to have for scientific notation? I'd have to have this be 2.982. I got to have just one digit to the left of the decimal place. So I have to have the number written like this. And then now the fact that I'm changing this, I'm moving the decimal really one spot, again, farther away from 0. That's what I like to think of it as. I'm moving it one spot away from 0. What's going to happen in this particular one? Well, now that I made the number bigger than it was, and I shouldn't say bigger than it is, but I've made the decimal go one spot to the left here, and now I've given it 2.982. I've gotten the number again another spot away from where the decimal should be if I wrote it in standard form. I'm going to end up increasing this power from 9 to 10 is what's going to happen. I'll kind of show you over here just to make sure you do see that. In this case, I'm going to end up increasing the power, and here's going to be my final answer. So this was 29.82 times 10 to the 8th. Well, again, what does this mean from the first lesson in this section? Meant that I'm going to multiply this number times 10 8 different times. That's going to move the decimal 8 spots to the, in this case, to the right. So 2982. I'd have to move it 2 spots to get it by the 8 and the 2, and then I'd have 6 more zeros. So 1, 2, 3, 4, 5, 6 for those next 6 spots. So here's really my number. In this case, 2,982,000,000. Well, if I want to write that in scientific notation, where's the decimal got to go? It's got to go right here. And how many spots away from that is from again, as I keep calling 0, I guess I shouldn't say that, but from where the decimal would be if I wrote it out in standard form? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So see how, in this case, I went 1 spot further than what it was before. So that's why I had to increase the power by 1 from 10 to the 9th to 10 to the 10th in this case. So that ends up being my final answer, and that's in scientific notation, 2.982 times 10 to the 10th. I'm going to go through one more you might see as well in this section. And again, also dealing with a rule that we've learned so far in Chapter 8. Look at this problem that I've got up here, 4 times 10 to the 5th, and then all that is to the 3rd power. Well, again, this may look familiar. Remember when we had some kind of term with a power, and then that was to another power, right? We called that the power to a power rule. Well, what happened in this kind of problem? And actually, this is the product, power of a product rule, because I'm multiplying. But remember what I could do is I can just apply this 3rd power to each of the things getting multiplied inside that parentheses. So I could take this 3 to the 3rd power, and then y to the 3rd. What happens to that? Well, that's the power to a power rule. That is right there. That's where I get y to the 6th. I multiply them together. So up here, same kind of thing. Again, I have some number multiplied by some power, and all that's to the 3rd power. I can just apply each of these things to the 3rd power. Well, what I get 4 to the 3rd times 10 to the, well, power to a power gives me to the 15th. Now here's the thing, this isn't really scientific notation yet. Again, the directions would probably say write it in scientific notation. 4 to the 3rd power is 64. So now I've got 64 times 10 to the 15th. Is this scientific notation? No, it's not. Where's my decimal point really? And if I have 64 here, it's really 64.0, you could think, right? And 64.0, well, that would not be in scientific notation. So no, it's not there yet. How do I really need to write this now? I need to write 6.4 times 10 to, well, it's going to be some power. I'm going to end up changing it again. And this one I think is going to be kind of like the previous one where, again, here was the decimal point, and I'm moving it 1 spot further than it was, right? And 1 spot further than what it should have been to have it in standard form. I'm moving it farther away from where the decimal should be. So again, that's my way of thinking. Well, from 15, I think it's going to go to 16. I'll double check it again here with us though, just showing us how it works. And this is the way you could double check it too if you're still kind of thinking about it. But if I bring this down here, 64 times 10 to the 15th. Well, in this case, since the decimal is already at the end, 64 times 10 to the 15th would just mean I'd be putting 15 zeros. 1, 2, 3, 4. I'm not going to count them out, but I'm going to have like 15 different zeros here, right? Well, let's say I filled all those zeros in. I'm not sure if that's 15 or not. Again, I'm just kind of guessing, but if I had 15 zeros there, now what I've done is I've taken it and moved it 1 more spot. So now I've moved it, I guess you could say, 1 more spot away, so that's why it ends up being 16 spots away. So that's why I now have 6.4 times 10 to the 16th. So again, these problems in Chapter 8 here using scientific notation. One, we need to know how to write a number in scientific notation. And then 2, using some of our rules from before. If all of a sudden we simplify the problem and it's not in scientific notation again, well, sometimes we have to modify it to make sure it is in that correct notation. Does look like scientific notation.